Hello there everyone, today's vlog will be all about physics. My name is Vanessa and today I'll be showing you some regular activities that I do while explaining the physics behind it. First up, we have the first law of Newton, which states that a body at rest will remain at rest and a body in motion will continue moving at a constant speed in a straight path unless an outside force will act on it. When I take a seat in the morning while drinking my water, I am already applying Newton's first law. My body tends to stay at rest, so when somebody decided to yank my chair, I will simply fall off. Here's a simulation of what would happen if that were to happen, because I would not want to experience my chair to be yanked off while I'm sitting on it. Hey Maria, do you know when Bobby is coming? I'm not sure. Oh, there he is. Psych! As you can see, I fell off on the spot when my chair got yanked off. Next comes the second law, aka the law that made you suffer. What's ironic is that you have probably known this law longer than you know your friends. It is only natural that when people are quarantined, they tend to get bored. And when people get bored, they find themselves a new hobby. For example, target shooting. This activity demonstrates the second law of Newton, which states that acceleration is directly proportional to the net force, but inversely proportional to the mass and also a little mix of parabolic projectile. Most people assume that bullets travel in a straight line, although in reality, bullets travel in a parabolic projectile while maintaining to travel as straight as possible. This is due to the gravitational force of the Earth that is pulling the bullet to the center of the Earth. Perhaps if Newton hadn't sat under an apple tree that day, bullets could have traveled straight. Just kidding. Each gun is built differently, and different bullets can give different muzzle velocity. The faster the bullet travels, the greater the force will be. But of course, there are other factors that can affect the trajectory of a bullet other than gravity and muzzle velocity. You also need to consider drag, air friction, and wind deflection. This activity also demonstrates Newton's third law, which states that for every action, there is an equal but opposite reaction. This law says that the force that the rifle exerts on the bullet is exactly the same size as the force that the bullet exerts on the rifle. And yet, the bullet gets much greater acceleration than the rifle. Why is that so? It is because according to Newton's second law, the mass and net force affects the acceleration of an object. The forces that were exerted on the rifle and the bullet are the same, but the mass of the bullet is smaller than the rifle. That is why the acceleration of the bullet is greater than the acceleration of the rifle. Other thing that I regularly do is of course bonding with my siblings. Hey sis.
Yeah?
Why did the chicken cross the road?
Why?
To meet the dummy.
I don't get it.
Knock.
Who's there?
The chicken.
Be ready. The trust will be picked up by tomorrow.
Wait, what? This is also a simpler concept of Newton's third law, in which I tried to bond with my sibling, but it backfired instead. That is all for today's vlog. Thank you for watching.